Hello, today we are going to take a look at question 11, container with most water. For this question, we are given an array of different heights and we are supposed to find out the maximum area that water can be filled between those heights. So it's a very straightforward question. All we need to do is look at this picture. So what's the maximum area the water can fill between these two heights? We can imagine it as a cup. So how much water it can fill, it depends on one thing. It's not depends on the longest heights, on the biggest heights, but it depends on the shortest heights. So we can see, the blue area, it is the maximum area this can form. And let's take another look. So let's pick these two, for example. What's the maximum area it can be? So it depends on the smallest heights. So it's this much. And so now you know how to get the maximum area it can be. So the question is asking between those areas, not between, among those areas, which area is the biggest area? So for this question, the biggest area is the one in blue. So how do we get them? So the first solution that easily comes to mind, that is we just violently solving it, which is we get all different areas and then we compete them with each other to find out the maximum area. That can work, but it's not very smart. It's a violent way to solving it, and the time complexity, it is the big O of n squared. And let's take a look. So to illustrate these problems better, so what we will do is we will go through the dumbest solution at first, then we go deeper. So let's first go through the easiest solution, the most straightforward one, which is compare every areas. So how do we do that? First, to compare them, of course we need some variable, some mutable variable that's always changing, updating itself, and eventually that variable will be the maximum area. Therefore, let's give this function a variable like that. And the next step, it is, so we have to pick two heights from those heights from this array. So to do that, how do we make sure that there's nothing missing? We need to use a nested for loop. So let's do a nested for loop for that. So this nested for loop, the first for loop, the first variable in the first for loop that is going to iterate through the whole array, and the next for loop it's going to be always looking for the height next to the I. So we're going to do it like that. And then we need to get the current area. So the way we do it is to do this like that, and we can see what's how to determine the area. It's based on these two lengths. The first length, this one is always j minus I, but we don't know which one's bigger, so we give it the absolute value of j minus I. And this one is always the smallest height between these two, so it's a minimum value between the height A and height B. Okay, let's first get the absolute value. We use this method j minus I, and next we get the smallest value between height I and height j. We get the smallest value, and then after we did it, then we start to compare each other. Compare the current area with max. If the current area is bigger than max, then the max will become the current area. And at the end, we will get a max, which is the max area. Then we return that. Let's see if it's working. Yes, but you can see here, this solution is not very good. It's only faster than 14% of the solutions, which means this solution is a very bad solution. Actually, it is similar to bubble sort. So the time complexity is O of n squared. And so next video I will explain to you how to analyze this solution to find out what steps we can just omit them, and to give it more efficiency, and what's the new solution, and how is it a better solution.